Episode 58 of the eBPF and Cilium Office Hours live stream. Today is a pre-record because my guest and I are literally on opposite sides of the planet. So hopefully at the point where this is streamed out at our usual slots later on today, I'll be online, able to interact with you on the YouTube comments. I think my guest will it'll be probably the middle of his night, but we'll meet Nick in a moment. Before we get to that, let's just talk through some of the headlines. I hope everyone who is watching today is already registered for the eBPF Summit, which is coming up at the end of next month. If you haven't already registered, do go and sign up. It's completely free to join, but it's always great to know who's going to be there, and it'll give us a way of sending you information as we run up to the event. We have not quite finalized the schedule yet, but we have got a few of our first speakers announced already. So go check out the site to see who we've already announced. The full schedule will be coming out in just a few days' time. The other cool thing that's happening this year for eBPF Summit is watch parties. And we're going to have people getting together in physical locations in Zurich, Berlin, Paris, I believe, and the Bay Area. If you want to organize your own watch party, there's information on how to do that on the eBPF Summit webpage. So a few other things that caught our eye this week. There's a couple of things that I actually think will be really fun to walk through on future eCHO episodes. This is one of them. This is something called Peach, but not spelt like the fruit, Peetch. And this is a walkthrough in this blog post about how to use this tool to, it says, bypass TLS protocol protections. And this walkthrough actually shows you how you can sniff packets and then grab the TLS secrets down here, which is pretty interesting. The next one is from our friends at Red Hat, and it's BPFD for BPF daemon. So it's a system daemon for managing eBPF programs. Again, this is something I'd really like to dig into a bit more, because I think it's really about how you load and unload different programs into the kernel. So yeah, I hope we can cover that on a future episode. And then the last headline that I thought was pretty exciting news this week is that Datadog have acquired Secret. And the reason why that kind of strikes me as interesting is really because these kind of acquisitions and mergers that happen in an industry really say something about how interested companies and the industry at large are in the technology. So the Secret team have been working in eBPF for a while, and clearly that expertise has been valued, and what they've been working on around API security using eBPF is something that has led to what I hope is for them a very successful acquisition. So congrats to them, and I'm sure they'll have a great time working with our friends over at Datadog. So that is the news for this week, and I think it's time for me to bring in my guest all the way from Australia. Let me welcome to eCHO, Nick Young. So thanks for joining us, Nick.
No problems, and I feel like I definitely should be saying g'day, everyone.
You definitely should. Whereabouts are you in Australia?
I'm in Sydney.
In Sydney, okay, great.
Yeah.
So yeah, and I'm in London, so we really probably couldn't be further apart physically.
Almost exactly on opposite sides of the world, yes.
But organisationally, we have just become quite a lot closer because Nick has just joined the team here at Isovalent. So welcome to Isovalent.
Yeah, thanks very much.
Yeah, and you've literally only been with us for, this is, I think, the end of your first week.
This is my first week.
We've thrown you in at the deep end to come and join eCHO show.
Yeah, no, I'm really excited.
Yeah, but I mean, this isn't, it's not your first rodeo. You've been involved in the whole world of Ingress and Service Mesh for quite a while now. So I know you're going to have a lot of expertise that you can share with us today. So maybe before we get into the kind of technical discussions of service mesh and Ingress and gateway API and so on, maybe just tell us a bit about your impressions before you joined Isovalent. What was your impressions of Cilium service mesh, and what kind of intrigued you about it?
Well, yeah, like I'll be honest, before, like, 3 or 4 weeks ago when it all became real, I hadn't looked into it too much, but I had heard a lot of people talk about it in quite complimentary tones. Yeah, I think it's really interesting because I think Cilium has a lot of capabilities that you would kind of classify as service mesh like capabilities anyway. Like the sort of blocking network access and stuff like that kind of is a lot of what you want to do with a service mesh anyway. And so, like, the addition of the Ingress stuff as well makes it sort of hits the gateway bits that other service meshes have. So yeah, I thought it was really sort of clever, clever product launch and a really good idea. And I think obviously I think there's still plenty to do. Otherwise, I wouldn't be here to do it. But yeah, like I think like I was quite impressed.
Yeah. I remember when I first joined, which was about 18 months ago, Thomas telling me that, Cilium was already pretty much an 80% service mesh because we already had load balancing, we already had observability, we already had lots of security elements. We didn't have absolutely everything, but we had a bunch of the component parts. So figuring out how to kind of map those to a service mesh was, has been the part of the work that's been going on for the last little while. But as you say, there's more to do.
Yeah. I think it's always the trickiest bit, right? Like, it's one of the things that's hardest about service mesh is like defining what it is and how you configure it and all that sort of stuff, right? And without wanting to jump ahead too much, like that's what some of the stuff that we're going to talk about with the Gateway API is all about.
Yeah. So actually, that's a great question. If somebody says to you, "What is service mesh?" How do you answer that question?
I usually say, like the way I like to think of it is, it's the solution to the problem you have when you have an actual microservice architecture. Right? Like if you have a polyglot microservice architecture, you need common ways to do stuff like, all of the things that you want out of modern services: circuit breaking and rate limiting, and preventing access to services that shouldn't talk to each other, but also enabling access to services that should. All of those things are the problems that you have when you start decomposing your big monoliths. Nobody needs a service mesh when you've got like a 3-tier app, like monolithic app, right? Like, it doesn't add that much, but when you've got like 200 services, some sections of which are talking to each other, you need a way to look at all of them all at once. And that's really what the service mesh is about, the problem that it's trying to solve.
Yeah. And I think for it kind of allows a separation of concerns between the developer of the business applications, who really shouldn't need to worry about how things are connected together, and then the platform team who have that concern of how do we offer this connected and secure and observable platform to our developers.
Yeah, exactly. And again, you're really taking words out of my mouth for some of the stuff that we've been doing from day one with Gateway API. So yeah, and so that's a large part of what we've been trying to do from day one with Gateway API. It's one of the reasons it's a mesh.
So you've been involved with Gateway API for quite a while. Maybe you can explain to us, what's the difference between an ingress and a gateway?
Sure. So I've been involved in the Gateway API since we first started it. When we first started it, we were originally going to call it Ingress v2. But then as we started looking at it, we were like, those services are type load balancers. They do something very similar. And so it'd be nice to sort of bundle all of this stuff up under one roof. So let's call it the Services API. And then we were like, this doesn't really, service is a bit overloaded. And so it doesn't really describe what we're doing. So we're going to try again, and we're going to call it the Gateway API. So we're stuck with that one now. We're not renaming it again. So the places where it came about are, there's sort of one of the things that the Gateway API is trying to do is trying to make it so that when you're taking traffic from outside your cluster to inside your cluster, that there's one way to describe it. No matter if you're coming in for layer 4, for layer 7, you do TLS, or other sorts of all sorts of full-on use cases that we've talked about off the top of our head, like GRE tunnels and stuff like that. The idea is that there's some language that's written in Kubernetes terms that can describe that for you. So obviously, we're starting with Ingress because Ingress, the Ingress resource is at the same time it's used by pretty much everybody, but it's actually surprisingly underspec'd when you start wanting to do anything more than like the really basic stuff. So if you want to just expose, company.com/ as using a Kubernetes service, it's great. You can make your things TLS, Cert Manager will handle all the TLS certs and stuff for you. But then if you want to do stuff that's a bit more clever, like maybe you want to set rate limiting or do some auth or something like that, there's nowhere in the spec of Ingress to actually put that information, right? So what people have done, and Cilium Service Mesh included, is people have defined a whole set of annotations that control their own specific implementations of those features, right? And that's kind of sucks in a way, because like it means that you can't pick up your Ingress and move it between Cilium Service Mesh and some other Ingress controller, right? So I think that's probably one of the biggest things, is that the fact that the spec is just there's not enough space in the spec to do the stuff that people who are doing more advanced stuff than the really basic stuff need. So yeah, everyone's ended up making these annotations, and no one's made the same annotations because no one has exactly the same use cases. So I think that's one of the biggest problems, and it's one of the biggest differences, is that for the Gateway API, what we've tried to do is firstly, we want it to be explicit. So everything that you can configure is in a field. So there's no annotations. Like annotations are anathema as far as we're concerned. You don't do any config in unstructured text, right? It's got to be a structured field that has API server validation and all of that good stuff.
Yeah.
And so the other thing that we're trying to do is to have it be extensible. So we built in the API lots of places where there's a sort of a core support option, but then there's places where people can add their own functionality on, so that you can build stuff that people are currently building with the annotations on the Ingress, and do it your own way if that's what you want. But it's still, but there's a spot in the API for it to sit. And then lastly, we wanted it to be role oriented. So we've designed the whole thing. We've actually broken apart the Ingress config, the services and stuff, so that it fits. We're targeting 3 personas: the person who owns the cluster, the infra admin; the person who owns the gateway implementation, I think we call it a cluster admin or something like that. But yeah, that's sort of the internal infra person, and then the person who owns the application.
Right.
And so the whole idea is to make it so that if you're an application developer, you don't have to care. If you have other people who can handle the other layers for you, then that's cool. You should be able to do everything you need by only touching the stuff that you control, and everything should work, and you should be able to figure out what you need to figure out without having to, build this whole stack yourself.
Right. So something like, I don't know, I guess it's fairly clear that if I'm developing a service A and I know that my service needs to talk to service B, I need to be able to configure A needs to talk to B, or my Ingress traffic at this URL needs to talk to service B. Do you consider it always the application developers' concern, whether things like circuit breaking and retries and canary rollouts and so on? How does that kind of map to those personas?
So we've tried to make it so that the personas can be broken apart by in different ways by different people. So it's completely fine for you as an application owner to say, hey, my service is described by this Kubernetes service that's available in my namespace, and then it's someone else's job to make sure that traffic gets to it and that it has circuit breaking and it does all that sort of stuff. Or you can draw the line and say, hey, as an application developer, I also own the HTTP route for my service, which is kind of equivalent in some ways to bits of the Ingress object, right? So right now, if I'm an application developer, I'd probably create a service and an Ingress if there's an Ingress controller running the cluster, and that's enough to expose my thing on the internet. So we kind of tried to make it so that it's kind of up to the owner of the cluster, like exactly how this stuff figures out. You have a bit of flexibility, but the idea is that if the service owner wants to control that, then if they control the HTTP route is where all of that stuff is going to be. And so all of that information is going to be. So that, in broad terms, the way that the API works is you've got sort of a few layers of config. You've got the reason the API is called the Gateway API is that the gateway resource is the thing around which the whole thing pivots. So the gateway resource describes listeners and addresses, and lets routes attach, and how routes can attach to those listeners. So for a standard Ingress setup, you'd have a listener that has like says, okay, I'm listening on port 80 and I'm listening on port 443, and I have certs for these domains, and routes can attach to those to the 443 listener or the 80 listener or both. And so then the HTTP routes say, okay, for my HTTP route describes the traffic, and I want to send the traffic for the prefix / to this service and the prefix / API to this other service. And so you can do some stuff with host names in both places, but in general, that's the split. Like the gateway defines like what ports your gateway implementation is listening on and what protocols those ports should have attached to them and any other details that they need. And then routes attach into those sort of listeners to sort of expose the route on each of those listeners.
Okay. So does that, when we say the word listener, is that the listener concept in Envoy?
It's similar. It's very similar in many ways. It's not exactly the same, but it's very similar. Yeah. A listener in Envoy is like a port that has a connection manager attached to it, and a bunch of filters on it. Practically, when you're using a Ingress or gateway controller that uses Envoy, that's how it ends up being set up. Right? I previously was a maintainer on Contour, which is exactly that. It has gateway API support, and that's how it works. Is that a listener in your gateway gets you a listener in Envoy, right?
Right, one-to-one mapping. Yeah.
In general, but it doesn't have to be that way. It's one of those things where a lot of the time with the gateway API, it's a bit hard to speak definitively, because one of the things we tried to do with the API is not bind it too tightly to any one implementation or technology. We tried to make it so just a general description of getting the traffic in and out of the cluster. And sure, lots of Envoy things do it the same way, but I don't want to say that's the only way to do it.
No, sure. I mean, it's clearly it's intended to be an API that supports multiple different service mesh implementations. So the underlying implementation, I guess it's always useful if people use the same terminology to mean the same thing, but we have many, many cases in the cloud native world where we don't do that. My favorite on that is namespace. Whenever people say namespace, do you mean Kubernetes namespace or do you mean like Linux namespace in the kernel?
I mean, or do you namespace your resources in their name by putting a domain at the front, right?
Oh yeah.
I mean, I know inside the gateway API, it's quite common that there, you might have like a text string that says, protocol HTTP or something like that. But almost every place where we have that facility where there's a text string like that, in the Go structs for it, we'll have like, this is a type, and we'll give you constants for the type, and those constants are like the core supported values. But in the API validation, we'll make it so that the string can be a domain prefix string, so you can have company.io / some other type. And that would mean that no one else's gateway implementation can do it, but it lets you go ahead. That's one of the ways that we've done the extensibility, is to sort of let you add your own protocol, and that will mean that gateway will only work with your implementation, but that means that you can figure out how that works without breaking everybody else, right? Like without having to wait for upstream to accept your idea.
Yeah. And that is one of those kind of happy compromises I think that we need in open source, in collaboration, where you don't want to have somebody who comes and go, this is the spec and everybody must comply exactly with this spec. You need to find ways that people can come together with their different implementations and find like the common path that allows slightly the variations.
So it's actually one of the other things that we've tried to do in the API. So we've also got this idea of support levels. So different resources and different fields inside the resources can have different support levels. So the three support levels are core, extended, and custom. Okay. So core is if you support the sort of overall resource like gateway or HTTP route, every implementation that supports that resource has to do this thing, right? So, creating listeners or doing name-based virtual hosting for like a HTTP route, like everybody's got to do that. That's core functionality. Then there's extended, which is you don't have to do it, but if you do it, you have to do it in a certain way, and we'll provide conformance tests that ensure that your implementation does it in a certain way. And then custom is open slather, do whatever you like. And the idea is that people can implement their own things in custom and then come to the upstream and say, rather than come to the upstream with a design and say, and have us be like, well, has anyone actually used this? You can build something in custom and be like, hey, we want to build rate limiting, and here's one we built earlier, and here's how it works, and here's the design, and this is custom in our implementation, this is custom support. Would you consider taking this and turning it into extended support or something like that?
Yeah.
And with the idea being that it's possible for people to do their own stuff and then show people how it works without needing to like to mess with the API and like fork the API or something like that. Right.
Like, yes.
That's the last thing we want to have happen.
Yeah. And that's a little bit more, I don't know quite what the word is, but it's better than annotations because it's a little bit more within the same structure.
Exactly. Yeah. There's a bit of a structure to it, right? And I think that the key part there is that intermediate step of extended, where you don't have to do it, but if you do, there's conformance tests that guarantee that you do it the same as everybody else who does it.
Yeah.
So that is useful for stuff that a lot of the time comes under service mesh kind of functionality, rate limiting or circuit breaking and things like that, right? Like the whole idea is you should be able to define that stuff in a standard way, and everybody, no matter how it's implemented, at the end of the day, the end functionality should be the same regardless of how it's implemented, right? Like if you're rate limiting, you should be able to say, hey, I've defined the rate limits like this, and if I go over that rate limit, then I get rate limited, right? Like you should be able to write a test that validates that anything that configures it in the right way does the thing that it's supposed to, right?
Right. Yes. Yeah. That makes sense.
Where it gets really complicated is that a lot of those features are very complicated and hard to define, and different implementations do things in different ways, and all that sort of stuff. The classic example is timeouts. You might think that it would be easy to define a stanza for how you do timeouts for a HTTP route. Turns out it's not, because everybody does timeouts differently. So if you are using an Envoy-based layer 7 thing, then Envoy has its timeouts sort of go from session initialization to here. There's a timeout that covers this part of the request timeline, and then there's a timeout that covers this part, and there's a timeout that covers this part, right? And then there's a timeout that covers like some other chunk. But if you use Nginx, then their timeout lines are drawn at very subtly different places. And so, aside from extremely coarse timeouts like overall client response timeout, which is not very useful, like the timeouts are so implementation dependent that it's actually not possible to write down a struct that would describe timeouts in a general way.
Wow.
Which I was pretty surprised about. But but we actually sat, I think Rob Scott from Google actually sat down and like went through a whole bunch of implementations and looked through their timeout things and figured out how they worked, and was like, there is just no way that they're not the same at all. They're in completely different timeouts.
Wow. Yeah.
Yeah.
Huh. I guess another one of these terms that perhaps has rooms for confusion is service. And we've said service several times in service mesh, and Kubernetes service. So what are the subtleties around the word service?
Yeah, it's a humongously overloaded term. And this is actually becoming a real problem. So one of the things that I alluded to earlier that we haven't really mentioned is that, so I'm going to take a quick digression and then I'll come back to the service mesh. Okay. So the Gateway API as it stands is like mainly about describing the transition point between things that don't have the in-cluster networking context and things that do. Right. So outside the outside internet and inside your cluster as an example. I talk in a guarded way there because sometimes you want to have like an internal one that's not outside things. But anyway, but it's if you think about it in traditional network diagram terms, the Gateway API is currently focused on north-south, not on east-west at all. A lot of the bits look like the stuff that you want to have for east-west, but there's nothing in the API yet that describes east-west. And so in the very recent past, like in the last month, a sort of sub-project of the Gateway API has come about called the Gamma Initiative, which, well done, Pete. That is an awesome name. I'm really impressed. It sounds like something from from the MCU or something. But I tell people I work on the Gamma Initiative, and people are like, "What? With Bruce Banner?" So the Gamma Initiative is about taking the concepts that we use in the North-South Gateway API and applying them and making a language to describe service mesh concepts.
We should probably just pause for a second and say, so North-South is outside to inside the cluster, and east-west is between, I'm going to say, services within the cluster.
Exactly. So within the cluster, again, I mean, Cilium has a cluster mesh, right? Like, so I personally would count stuff between clusters, between services in different clusters in a cluster mesh as east-west.
Yes,
right?
yes, that
right?
makes
Like
sense.
it's not within a cluster. Again, that's one of the reasons you've got to be a bit vague and hand wavy about the language here, is because people are like, oh, but what about if it's not in the same cluster, but it's owned by the same administrative entity? It's like, yeah, sure, that's east-west too. Right?
Great
So,
point. Yeah.
And so, people often look at me funny. I'm like, can't you just say outside and inside? And I'm like, well, I can't, because that doesn't describe all the use cases. To go back to the service question. So, as part of the Gamma thing, like the fundamental thing we need to start with is like, what is a service mesh? What does it mean to have something be a service mesh, right? And that and it's surprisingly difficult, right? Like, as we said before, like everybody has different ideas about what a service mesh is. And so it was one of those things where we all started talking about it, and then we were like, oh, so we need to talk about what a service is. And then everyone had different ideas there too. And we were like, well, it turns out we need to talk about what a service mesh is first, and so that sort of implies what services are.
Yeah.
And so one of the things that we found is, it's been really hard writing this down, because, and the conventions we've settled on is that capital S service means Kubernetes service, the resource, Kubernetes service. Lower S service means the generic concept of the service. But this is the sort of trade-off you have to make and be clear in your definition, so that when you're talking to people, people know what you mean. And then even when you're talking about a Kubernetes service in a service mesh context, there's one of the things that, so Keith Maddox from Microsoft has been like one of the people driving it, and he's working on a gateway enhancement proposal at GEP, which is analogous to the KEP for our main project, about just defining what a service is. And one of the things that he brought up is that a service in a service mesh is really the combination of two things. It's a front end, a name, an identity for the service, like that you would see in a service catalog. Sometimes that includes like a TLS identity or a SPIFFE identity or something like that as well. And then there's a set of endpoints, right? In the main part, in the north-south part of the Gateway API, you only care about a Kubernetes service as a bucket of endpoints, not as a service identity, right? Because you don't care about what the name of the service is. All you care about is that you're taking the traffic from outside and getting it to the endpoints, right? And so you only really care about sort of this like back-end part of the service. Whereas in the service mesh, the important part is the front end, because the identity of the service, because you're talking about, can service A talk to service B? And then the identity of service A talk to the identity of service B. And maybe that ends up being implemented as like IPs and stuff like that. But the important part, the part that the person who's describing it wants to be able to do, is to say, I want service A to talk to service B.
Mm-hmm. Mm-hmm.
And this is what I mean by it. Like this, I have a lot more sympathy for people who write RFCs for the IETF, and about how hard they are to read, because after writing a spec like this for a long time, because it turns out, you have to spend thousands of words defining what your terms mean before you can actually go and start talking about it. Because otherwise, when you talk about it, people are like, oh, but no, the service doesn't mean that. And you only find that out after you've been in a meeting for 3 hours, right? And everyone's arguing forwards.
Yeah, I guess it's like law as well. If you have a contract, it starts with the terminology defined at the top, and I think that's the thinking process is very similar, isn't it? We have to be extremely clear about what we mean when we say
exactly.
So,
exactly. And so that one, I think we've got one of the things we've started doing recently as well is, so like KEPs, you can merge a GEP and have it be approved in a provisional fashion, and then an implementable fashion, and then be implemented. And so we have I think the initial, like, what is a service mesh GEP has been merged as provisional. I actually did that this morning. And then there's another one about like how we're going to describe services. And then that one is then going to be the basis of how we need to start thinking about, okay, how are we going to attach routes to services, right? Like, because usually when you're talking in a service mesh, you want to be able to say stuff like, you want to treat the consumers and the producers of a service slightly differently, right? Like, as the owner of a service who wants to expose it to people, I want to be able to say, hey, I'm going to make this service available in some sort of service catalog or something like that, and I want it to have these rate limits because I want to control that and stuff like that, and I want to route. I actually have a couple of microservices that I want to hide from people, and I want to route different prefixes to different things. in that way, it's a little bit like Ingress and the north-south. But then on the consumer side, that's where you might want to say, hey, when I'm reaching out to this thing, I don't want to, I want to rate limit my own reaching out to them. But that's a different rate limit to the one that's on the producer side, right? Like these are reasonably standard operations for a service mesh to want to do, right? Like if I make a mistake in my programming, I don't want to break someone else's thing. I might want to rate limit my own thing, or I might want to have a circuit breaker my own circuit breaker that for talking to someone else's service, even if they haven't done theirs. And so there's a real big difference between the consumer side service and the producer side service. And we've got to figure out some way to describe that difference. Right? And all of those things are similar to constructs we have already, like in HTTP route and stuff like that. But again, they're just different enough that you can't just use the same things again easily. If you are going to use them, you've got to be really careful about how you talk about them.
Right. So there's going to be quite a lot of work by the sounds of it to, I guess, achieve the definitions of what people are talking about in these different APIs and the APIs themselves. But meanwhile, presumably, implementations will be happening to prove out whether the ideas work, whether it all hangs together.
Yeah, I mean, I think to bring it back to Cilium Service Mesh for a minute, right now, like for Cilium Service Mesh for the Ingress stuff, we only support the Ingress resource. We have no annotations and stuff like that. So one of the things that's going to be on my list to help with and to work on the design for is to get Gateway API implemented in Cilium Service Mesh so that we can use that for the north-south traffic, the stuff that's already built. Yeah.
Which I think will be, really popular. I know when we've been surveying our users and during the beta phase of Cilium Service Mesh, Gateway API. And so maybe actually explain a little bit about how SMI relates, or if it does relate to Gateway API and the Gamma initiative.
Yeah, so I think SMI was the Open Service Mesh and a bunch of folk from Microsoft and others. It was their attempt to generically describe the idea of service mesh. And I think one of the things that they really got right is that a lot of people don't want the full service mesh Monty, as it were, right? They want just like, they're like, oh, I like this idea of a service mesh, and I like my things to have an identity and to be able to do the access control, but I don't care so much about the observability, which I think that would be a mistake in my view. But like, hey, that's what some people want, right? Like, and so being able to pick and choose bits of them and only use the bits that you want, like, is really valuable. And being able to bring people along the sort of service mesh journey and to understanding why it's a good thing a little bit at a time, rather than being like, here's like 20,000 lines of YAML to install in your Kubernetes cluster, and now you have everything, right? Like I think that's I think that's one of the things that they got really right. And so SMI was like an attempt to do the same work that we're doing with the Gateway API, but they had the same problems that we're having in the Gateway API, but worse, because they didn't have like any constructs already that people had sort of looked at and really understood. But in Gateway API, we've at least got the idea of a gateway and the idea of HTTP routes. And we spent 3 years like tinkering with those and tightening up the language and tightening up the specs so that they actually describe something. And so now, so we're not starting from nothing. We've got a little bit there at least.
Great. Yeah. So Gateway API will be another way to configure Cilium Service Mesh. And I guess it's probably worth just kind of talking a bit about how Cilium Service Mesh gives the data plane. So we're using eBPF connectivity to create the data plane that connects between your ingress and a service, or between one service and another service. And we're using Envoy for the layer 7 parts where we need to do layer 7 terminations. And yeah, I think you already mentioned, we today have that integration with Kubernetes Ingress. So I guess there will be a similar or work involved today. If you have a Kubernetes Ingress defined to be Cilium Ingress, that will program the Envoy proxy to achieve the data plane that matches that ingress. And I guess there will be work involved to do the equivalent thing for Gateway API. So to program the proxy with what's configured in those gateway resources. Is that about
Yeah,
the size.
exactly.
Yeah.
Exactly. Yeah. And again, the idea here is that, right now to do that, there's a bunch of annotations you've got to put on your thing to make on your Ingress to make sure that it does that, to direct more closely how the Envoy config comes out and if there's any sort of more advanced stuff you want it to do. And the whole idea is that those annotations will turn into fields in the sort of Gateway API resources.
Yeah, which will be more easily tested, I guess, and more easily. We can have conformance tests like we mentioned before. Yeah,
exactly. And and I think that at the end of the day, it's going to come out being easier. So there's easier for users. I think there is absolutely a complexity overhead because having, I didn't finish talking about the resources before. So the resources are broken up into like the gateway resource, and then it has routes attached to it. So there's currently 4, 5 actually types of routes in the core performance. There's HTTP route, TLS route, TCP route, UDP route, and gRPC route.
Okay.
So HTTP route is pretty self-explanatory. That is for terminated HTTP traffic. So if you have TLS and it terminates and then you start a new HTTP session, TLS route is for unterminated TLS that is discriminated on the basis of SNI. So that means that, so if you want to run if you want to describe a listener that will look at the TLS and then use the SNI to forward TLS for different domain names off to different services, you can do that.
Without doing any kind of termination or decryption. So it's passed through, still encrypted all the way to the service, right?
Yeah, but the good part is that it's passed through, but because when you proxy TLS, you still get enough of the TLS handshake to see the server name indicator. It means that you can have one TLS listener that listens for an arbitrary number of services as long as they all have different host names.
Right.
Yeah.
Right.
So that's really
and you can do that by having those host names mapped to different services, I guess.
Exactly. Yeah. And and then you've got TCP route and UDP route. Those are exactly what you would expect. They can route traffic based on the 5 tuple, right? Like source, address, source port, destination port, and protocol. TCP.
Right.
UDP. Yeah. So and they've been basically you can have traffic go to a different service based on where it's come from, or the IP address it's going to, or the port, or that. But that's all the information you've got at the layer 4 level, right?
Mm.
Yeah, and then gRPC route it's actually like a special case of a HTTP route. So there's nothing you can do in gRPC route that you couldn't do with HTTP route. It's like syntactic sugar on top of HTTP route.
Okay. Yeah, that makes sense. Okay, so you've got your different routes. What other resources do people have to worry about?
And so your routes, there's a way that you attach your route to the gateway. That is like your route basically says my parent gateway. It has a list of parent gateways, and it says my parent gateway is this gateway, name and namespace. And the gateways have a gateway class in the same way that ingresses have an ingress class. Gateways have a gateway class, and the idea is that the gateway class sort of describes a shared configuration across a set of gateways. And then aside from that, there's a bunch of other sort of supporting resources. Probably the biggest one that's the most important is a reference grant. Now, a reference grant is about ensuring that for resources where we don't control the spec, if you want to do a cross namespace reference, then you can do it in a way that's that respects the security about cross namespace. So one of the problems with doing cross namespace references in Kubernetes is that in general, the security boundary is the namespace. Right? Like that's kind of the fundamental security unit of Kubernetes, right? Like doing security at like a more granular level than the namespace is really dangerous. And so if I have a route in one namespace that wants to reference a service in another namespace, if you think about it, like if the service owner has no way of saying, like the service resource doesn't have anything in it that can say, hey, don't allow routes from this spot. When we built the gateway route one, we built it so that there's like a two-way handshake. The route says, I want this gateway to be my parent. And then the gateway says, I will allow routes that match these criteria. And so there's like both parties sort of consent, and then so it's the same. You really want to be able to do the same thing for other resources like service, or more importantly, secret. But there's no space in those APIs to do that. So we built this resource called Reference Grant that says, okay, so you've got a gateway. You want to stand up a gateway for company.com. I am the owner of the certs for company.com. I want to put them in key pairs in a namespace you don't have access to, but I want you to use them, right? So I want you to be able to do TLS for it, but I don't want you to be able to see the key pair. And so what you can do is I can create a secret in like super secret namespace, and then I can create a reference grant that says for secrets in this namespace, allow access to them from gateways in your namespace. And then, when your gateway tries to use that secret, that's like you're saying I want to use it, and I'm saying I've allowed you to use it. So there's a two-way handshake again. But that requires an extra resource because we can't mess with the spec for secret or for service. It's the same thing for service, doing cross namespace service references.
Yeah, and I think this speaks to something that I think is quite interesting around, how people think of the security of traffic coming into their cluster, where there's lots of different ways of kind of cutting things up. But I think it is quite a common model that people will have, let's say one gateway that is the ingress for multiple different services and possibly multiple different namespaces. So even if you have multiple teams who, act independently and have their own sort of security boundaries around their services, the traffic might all actually be coming in through one common gateway. And I think that's something that sometimes gets lost in the discussions around how the security boundaries work in Ingress traffic.
Yeah, absolutely. And it's one of the things that's been really on our mind. And it actually, Rob actually found two CVEs in upstream Kubernetes based on us trying to build out this stuff, because all of us who make Ingress controllers, it's quite common to just be like, hey, you can reference any service you like. And the problem is, if you create a service of type external name and your Ingress lets you point to any name, there's nothing to stop you creating a service of type external name. So if I've got, you've got super secret app in your super secret app namespace and it has a super secret app service, I can create an ingress in my namespace that has an external name of super secret app service.supersecretapp.service.cluster.local. And if the ingress controller lets you do an external name, then it'll be like, oh, okay, I'm just going to take that traffic, and that traffic needs to be fronted by the cluster local domain name of that, and then your proxy will go and look up that domain name and find the endpoints and helpfully configure it for you, and boom, any access control you have around super secret service is now gone. Pretty scary. And then the other thing that you could do there is the other one that was even worse was if you have a proxy setup that is done with an in-cluster proxy, you can say, I want to expose services on the external name localhost. Oh, and then you can connect back to the admin port of the proxy and say, stop the proxy or take control of it or read stuff that you shouldn't out of it, right? Like really bad. And so so Contour at the time, I was just like, no external names, end of story. Other people have a more nuanced approach than that, but I was like, that's too scary. And then the other one was another one with having manual endpoints. But it's the same sort of idea. Like you end up with there's a real possibility of confused deputy attacks when you're not really careful about making sure that everybody who's doing this cross namespace stuff agrees to what's happening, because of necessity, your service mesh or your ingress controller has to have extremely wide-ranging access to the cluster. Like they have to be able to read secrets from everywhere, and they have to be able to read, objects from everywhere. And so, if you can ask that thing to violate security for you, then you're in happy jam, right? Like as an attacker.
Yeah. And I think we've seen some of the concerns about, and I think that that there is a discussion to be had about how if we have a shared proxy in Cilium service mesh, shared between multiple different services, possibly shared across multiple different namespaces, because we can support a proxy per node. And there's been a lot of discussion about whether that is a security concern, and I think a lot of that discussion kind of doesn't take into account that, well, if you're already passing all your ingress traffic through a single proxy anyway, then probably worrying about having separated proxies within the cluster may not be your greatest concern. Not to say that you would have more more layers of defense if you had more different proxies. There's always going to be a trade-off between complexity and and if you make things so complex nobody can use it, it'd probably be really quite secure. But
yeah. I've what was the thing? Like I remember hearing something. It was someone be like, "Oh yeah, like it'd be much easier for kids. Kids wouldn't have to worry about learning to walk if you grafted them to small motorized carts when they were kids. But then they didn't have legs, right? Like, kind of sucked. Like, so like it's the same sort of thing, right? Like, there's ways that you can make your system, a perfectly secure system is perfectly useless, right? Like,
yes.
Yeah. And so I mean, I think with the sort of the multi-tenant traffic passing through a single proxy, I think absolutely that is then a single point that would be really attractive to an attacker. But all that means is that you've got to be careful with it. You've got to treat it like the single point of risk that it is, and make sure that not everybody has access to it, and that the thing you're using is reasonably hardened and doesn't share information across across tenant boundaries inside it. I think Envoy is actually very good at that. Like, if you have a separate filter chain per like TLS header, say, like, then you can't get the TLS secrets out from one or the other. I mean, if you're using plain text HTTP, that's not the case. But if you're using plain text HTTP and you're worried about security, like, I've got some news for you. Like, you're not in a happy place. So I think there's absolutely stuff that you can get wrong with Envoy about that sort of stuff. I think we certainly found the thing in Contour about like how you handle like reconnections and connection coalescing for HTTP2 and a bunch of other stuff like that can cause problems. But again, it just means you need to know what you're doing and be careful and manage the risk. And as always, that's what it's information security is about, is risk management, right? Like,
absolutely, yeah.
This is at the end of the day, having it go through the single thing, you're saving a lot of resources and increasing your risk a little bit. Like, that's, I think, what it comes down to. Like, sure, it is absolutely an increasing risk. Is it a manageable increase? We believe so, right? Like, or else we wouldn't be doing it.
Exactly, and there are lots of cases that we've seen from from users who've been really excited about service mesh, where they've said that service meshes have been too complex or too heavyweight or too resource intensive for them to really consider up till now. So having an easier, simpler model could be a real benefit for a lot of people, and certainly reduced latency is a huge. I know quite a lot of people who've had concerns about latency, and hopefully with the high performance eBPF data plane, we'll be able to address those concerns and allow people to take advantage of the other service mesh features. So it's going to be exciting times.
Before my previous role, I was at a long time ago. I was founding team member of the Kubernetes team at Atlassian, and when we were looking at service mesh stuff there, a lot of the developers rightly had the question of like, oh, but if you're building this service mesh thing with all these inline proxies on every side, like, aren't you adding like a whole bunch of hops? I'm like, yes, you are. Like, but I think a lot of people who use sidecar-based service meshes are like, again, they're making a trade-off. They're saying a few extra hops is worth it for the developer savings you get by not having to have everybody implement circuit breaking and some people getting it wrong or something like that. Like, so trade-offs, right? Like, and so I think the trade-off that we're making here is, like I said, saving resources, and you're trading off a little bit of security and it's a big resource save, right? Like a big resource and latency save.
Yeah, absolutely.
So and the thing that I really like about working on stuff like the Gateway API is that the whole point then is to make it so that that there's a place where we all come together and we describe the stuff that we're all trying to do together, and then that lets us compete with each other on stuff like, do you have a sidecar or not, rather than can you support this feature or not, right? Like, that you describe the features for everybody, and then we compete on the stuff that's actually interesting to compete on, not on like not on silly things like have you implemented rate limiting yet, right? Like, or something like that, right? Like, I think it's much more interesting for customers to have, and users to have, a really good choice and be able to make their own trade-offs and have various options that support different people's use cases and have their own use cases. But at the same time, the good thing about having an upstream API like the Gateway API is that it's specifically designed to make it so that vendor lock-in is hard, right? Like, so you're not by choosing to use someone's service mesh, you're not stuck with that service mesh forever. If you decide that you want to make a different trade-off, you should be able to pick up that stuff. And in the glorious future where the Gamma initiative has finished its work, like a lot of what we configure today in Cilium with our own stuff, like should be configurable with service mesh constructs, right? Because like you said, like a lot of Cilium's features are described by service mesh constructs, like service A can talk to service B. If there's a way that you can describe that with the gateway API, it'd be really cool if you didn't, you don't have to learn that. You can just, if you learn the gateway API, you're done. You can, that would be really cool.
Yeah. Did we cover all the resources? I'm conscious we went off. We covered all the resources. Good.
Yes. So reference grant was sort of the last really big one.
Right.
That's, I'm kind of proud of that one. Like that was a lot of that was Rob's and my, like we worked really hard on that, and we actually had really good. Rob actually took it to API Machinery, and they were like, "This idea is interesting. Maybe we should consider. Like maybe we should start the gears grinding towards making this a thing in core." Because I think that would be a really good idea. It'd be really nice for there to be a standard way to make safe cross namespace references without having to think about it too much.
That's true. There's probably other types of custom resources for where being able to make safe decisions about who has access to different secrets would actually be really useful. So I can see the attraction of making that a core part of the API. Yeah.
And I think there's probably one other thing that I should mention, and that's also a similar idea. Like reference grant is like a meta resource that talks about the binding between two resources, the connection between two resources, not a network connection, but like a logical connection. And we also have the idea of a policy attachment. So the idea of implementations being able to write their own custom like CRDs that fit like a certain shape, and then say if you make your policy, you can have your policy say attached to the gateway, and then have those settings flow down to routes that are attached to that gateway. The classic example is that timeout thing I was talking about. So one of the ways that I hope that policy attachment would be able to solve that is that we can write like an Envoy timeout policy resource, and then you can attach that same Envoy timeout policy to a route or to a gateway, or even maybe to a gateway class, and say, so as a infrastructure or a cluster admin, you can say, I have only a single proxy data plane. I don't want people to be able to do infinite client timeouts and have connections never time out and have problems with connection exhaustion, stuff like that. So I'm going to put a mandated thing that says you can't have an infinite client timeout. You can have a large one, but you can't have an infinite one.
Right.
So and that's exactly the sort of capability that the policy attachment mechanism is designed to do. It's not very well implemented yet. It's a bit sort of arcane and abstruse to sort of understand. So I don't think a lot of people talk about using it a lot. I haven't seen people use it heaps and heaps yet. I'm really excited about what people will do with that, though.
Yeah. So we're getting close to the end of the hour. I think maybe we should finish by just talking about, if people are excited about service mesh and Gamma, and in particular, like getting Cilium integrated with the Gateway API, how can they get involved?
Well, so in terms of the upstream itself, like in terms of the Gateway API project, on the Kubernetes Slack, there's a SIG network Gateway API channel that is where all that coordination happens. There is a website that I have put in the show notes. That is the base Gateway API website. There's also a page on there about the Gamma initiative. Any of those things, there's a bunch of community meetings and stuff like that for the upstream one. That's if you're interested in contributing to the API itself. There's absolutely plenty of work there for people who are interested in API design. But in terms of actually building, if you want to get closer to the coalface, as it were, and be working on implementing the things that we're building in the upstream, then I think the service mesh channel in the Cilium Slack is the place to go.
Yeah, fantastic. And I guess you and other folks who are working on service mesh are there in the Cilium Slack, as am I. So folks, if you're watching, come and say hello. We always love to hear from you.
Yeah, absolutely. Yeah.
Brilliant. So if before we close up, is there anything else that you wanted to
no, I think that's pretty good. Yeah. I think I've talked enough, probably. These are like, I have been working so hard on this for so long. The hard part for me is like shutting up and letting other people have chance to talk about it. It's a real baby of mine. So.
Yeah, well, I'm so excited that you're able to carry on working on it, and I think the service mesh community is going to benefit a lot from this work, and Cilium users as well. So we're excited to be working with you. Yeah, wonderful. So I think that pretty much wraps us up for today, and so thanks again to Nick for joining me, and everyone else. I hope that, because again, this is a pre-record, so I hope that by the time you're watching this, we've been able to interact on YouTube. If we have any questions that we can't answer live, we'll just deal with them in Slack. So yeah, come and say hello in Slack. We'll see you there, and hopefully we will see you next week on the eCHO live stream hosted by Duffy. See you again.